Welcome to the lecture series. Here we are going to start with the lecture series of embedded system and programming. So first of all, before getting into the embedded system, we have to know about the microprocessor microcontroller. So starting from the microcontroller architecture, what exactly is a microcontroller? It is nothing but a compact computer on a single integrator circuit. That is nothing but your 8051. It is programmable and designed to execute a specific task repeatedly. So you can find it out in the embedded system like a brain of every smart devices and electronics. So coming with the microcontrollers are a single chip solutions. They integrate the process, memory and input-output peripherals. And this make them ideal for the embedded applications. For example, washing machine, starting from the basic washing machine to the higher end versions. Coming to the 8051, because before getting into one controller and IC, we have to know 8051 IC pin configurations. So this is the basic configuration where you can find 4 ports starting from port 0 to 1, 2, 3. So you have 4 ports, and port 0 acts as your address data pins. So you can use it for fetching the data from the memory to processor, processor to memory. And second port also is a continuation of your address pins, and port 1 acts as your input output ports. You can use it as either as an input or output ports, and you can use it for the external peripherals connections. And apart from that, you have port 3 for your receive and transmitter, interrupt pins, timer pins and read and write options. So these timer pins is used for performing a specific state functions, and this interrupts are used for uh, sub, producing a small task in between a main task. So you can introduce a subtask in between your main task. And coming to the receive and transmitter, you can use this for when external peripheral is connected. And apart from that, we have the crystal uh, clock signal here, that is XTAL. So this crystal frequency clock signal is given to start your microcontroller to respond to the signals. So once this crystal frequency is adjusted, the response will be adjusted. So if the crystal frequency is tuned up and down, according to that frequency, your performance will be reflected. So this is the basic pin configuration, and apart from that, you can see address slash enable and programmable. That is, you can switch to either to receive or to program. So if I want to rewrite the program, I can go for the programmable option, or else I have to run the application, and depending upon the input fetched, the if I have to react, I can switch to the address slash enable. And here we also have program enable and VPP and VCC for the voltage, like a basic voltage for your microcontroller. And core components, as we discussed, we have CPU, input output peripherals and memory. And CPU is a basic brain of your embedded system. And we have interrupt controller like external internal interrupts, which we can use it to introduce a subtask. And coming to the memory, here we can find 4K byte ROM and 128 byte RAM. So this is the basic two memories we have inbuilt. And in the microcontroller, you have an inbuilt memory, whereas in the microprocessor, you don't have an inbuilt memory. And we have a timer circuit here, like timer 0 and 1, which we find it in our pin configuration. Yes, and we have the input output pins. So 4 pins, that 4 ports may act as input output pin, whereas this port 0, 1, 2 may be used for address data enable, and port 3 can be used for your external interface. And apart from that, we have CA port used for receiver and transmitter. For example, if we are using any other interface along with the microcontroller, in that interface module may have a receiver transmitter which can be connected to this portal. And here we have discussed about XTAL, that clock frequency, like oscillator clock frequency. Yes, you can find it like oscillator clock frequency circuit to modulate your performance. So ideate. So what is the next step is, we have program memory, that is nothing but a flash, which is a non-volatile storage for the firmware, and this acts as an MCU's operating instructions. Next, data memory, addressing modes, and EEPROM. So these are the types of memory, and these memory basically plays a vital role because storing the data and executing the data reacts in the system's performance. And prototype interfacing with the external peripherals, we can go with the GPIO, general purpose input output ports, UART, SPI, I2C, that is your communication interfaces, and timer and counter circuits. And ADC, DAC is nothing but analog to digital, digital to analog converters. They can be used with the analog, convert the analog signals. So last, we're going to know the instruction set or instruction flow. So we are discussing about the just a flow of microcontroller. So first it fetches the instruction, it decodes the instruction, and after decoding it executes a task, and again it write back the result. So it is very simple, right? So beyond the basics, we have interrupt, preset, and power management. Interrupt is nothing but the event-driven program execution changes, allows handling the external events. So subtask, that is but to execute a subtask. Reset option, it restarts the microcontroller. Power management is comes under the optimization of power consumption. So in the next lecture series, we will consider the next like addressing modes, interrupts, in and the instruction sets in detail. Thank you.